a look at that part two of the project. There is a conversation I had with one of your classmates, and I thought it was a healthy conversation, and I should probably pass it along to you guys just so you have the same insight. So you're looking at part two, and you're basically at the point now where everybody should be at part two, this optimizing. I mean, you've picked some kind of demand curve out of the choices that non-linear, because I chose the linear one. In fact, I'm going to talk about that linear one here in just a second. I have that all ready and waiting for you off to the left-hand side here. But you can choose quadratic or logarithmic or cubic or anything that works that was a reasonable fit. I'm not going to be too picky on that. What I am interested in is the conversation around number two. It says, all right, find your demand curve, the best one, or at least justify the one you chose as being reasonable. And then determine a selling price that generates maximum revenue. What's the maximum revenue? All these questions in here. And then the special twist part was if you sell 15,000 shirts, then you get a $50,000 bonus. And I kind of thought I'd look at how that looks because this friend of yours, fellow student, was just kind of confused how to think about that. So I have a little insight for that. Here are some graphs. So I chose a demand curve that was linear, and I chose X to be the number of units sold. And so when you look at my graph over here, you'll see like big numbers in the x-axis because they're units, 15,000 units. And in fact, because 15,000 is such a big deal, I even graphed x equals 15,000 so you can see it in there. The top graph is my revenue curve. So I took x times my demand curve, and then you can kind of see a peak in there. So if I'm going to maximize it, I can find that. And then the second one's a profit curve that I've put together, and which is just minus the cost, which is kind of a fixed deal for all of us. And the third curve is if I want to add a $50,000 bonus for selling 15,000 shirts, that's that purple curve on top. And everything else I think falls into place. So a couple of questions we can answer. All this on Desmos I think plays out pretty nicely. I'm just going to click on this graph and talk you through it like I did with your classmate. Basically the deal is maximizing revenue is no big deal. It's finding the peak up here. So if I get a peak revenue on a standard red, this is my normal revenue curve. The peak is at 15,910 units, $278,425. The way you find out the price that goes along with that is you actually have to take that number of units, you have to plug it into your demand curve, like I've done down here, and find out what's the price that goes with it. So I've done that here. Well, if we sell 15,000 units, then we're actually following this purple curve up here. So 15,000 or more, right? That's the deal. So what I thought I'd do is I thought, well, where's that fall into play? Where's this 15,000 units? I did it on the graph by drawing a line, vertical line that's orange. I also plugged it into my demand curve to see what price that drew up. And this is the conversation we had. So basically, they were saying, well, how do I read this? How do I interpret what's better? Obviously, I want the 50,000 bonus. So what it meant is to maximize my revenue under just following these standard procedures, I would sell 15,910 units at $17.50 a piece. Now, this is according to my model, my linear model. Yours will be different because nobody's using the linear but me. And the 17.5, that's a good price. If I want to sell 15,000 units, that's what the bare minimum is for the bonus I get from the Drake Board of Trustees. I could sell them for $18.50 a piece. Great. So what that says is I'm in a pretty safe place by selling it at $17.50 for my maximum revenue. I'd sell 15,910 units. I'm pretty safely going to achieve the bonus as well. So really what happens if I sell them at $17.50 a piece, I'm going to be shooting up here to the other peak up top here. I'm going to be looking at this revenue curve to find the purple revenue curve to get the maximum there. That's a good deal. The deal is, though, if I get up my price too high, if I get to $18.50, I'm only going to sell 15,000 units. I'm raising the price to $18.50. You can see down here on the lower left. If I do that, I'll sell fewer units. So you have to decide $18.50, you project selling 15,000. We all know that reality is never going to be exactly what the projections give to us. And so you get to choose a price and come up with a reasonable estimate. Based on this information right here, these graphs that are on the page are enough to make the decision given my data, my models. So I'd say, wow, I wouldn't want to sell it for $18.50 as much as I like, the added profit. In fact, there's doubly good reason not to sell it for that price because, frankly, I can make more money if I sell it for $17.50. I can get that's my peak in my revenue curve. That's great. And it assures me 15,910 sales, and I'm going to get that bonus. So really, I'm sitting here riding this curve up top. This is where I really get it. This is awesome. Look at that. There's my peak. I'm actually sitting up here making $328,000. So that was my safe move. I'm not going to, but I also want to mention though, in my explanation for the question in the project is, I know what the price is that'll get me 15,000. I don't want to be that close to that price. I want to definitely be below it. It is to my advantage to have it a price lower than 1850 to assure 15,000 or more sales. Everything else, I hope that kind of gives you a perspective on what the graph should look like. Just kind of look at my equations. Hopefully you can know where they're coming from, the graphs there. This is good justification. I mean, I would take a picture of this graph and get it into, you can copy and paste these and then talk in and around that graph or the equations and things like that. Just justify the things you say. That's the conversation. Hope that